have a system of linear equations. And I'll show you the theoretical format that I'm using, Kramer's rule. So for the theory, we'll apply Kramer's rule. And how does this work? In order for you to use Kramer's rule, you have to understand determinants. So this is going to be employing determinants. Let me just... And so what is a determinant? So the determinant is defined by this, I think MATLAB uses the command. MATLAB command is det. But if you have a matrix, and the matrix has to be square. So if you have a matrix, and let's say the matrix is, come on, 1, 2. One, 3, 6, 5. And you want to find, let's say A equals. And you want to find the determinant of A. We usually use the notation in MATLAB det for the determinant. That would be the command that you'll be using, det of A. And MATLAB will give you a result. And it will be a scalar, a number that it will be generating for you. And so how do I find this determinant of A? And first of all, the representation for determinant is going to be using 2 straight bars. So you will see something like this, 1, 3, 6, 5. So when you see those straight lines, it means that it is the determinant. In mathematics or in linear algebra, that's the symbol that we use. So even though this looks like a subtle difference here, you see here that I have this bracket here. This is just a straight line. And to calculate the determinant of the matrix has to be square, so it has to be has the same number of rows as columns. Then the way you will do it is this. You're going to multiply going this way 1 times 5. You're going to subtract 6 times 3. You will end up with a scalar value. So for this guy, if I want the determinant of A, it is then 1 times 5 minus 6 times 3. So here, what we are having is 5 minus 18. And the answer, of course, is minus 13. So the matrix has to be square for you to find its determinant. And so this is the simplest form is a 2 by 2. If I have a bigger matrix, a 3 by 3, I can break it down into what we call cofactors, which are going to be smaller determinants. But let's not even go to the 3 by 3 yet. Suppose we had another matrix. Suppose I said we have B. B equals, and we're going to first start with a matrix, and I'll just say 10, 20, let's say 0, minus 8. And somebody asks for the determinant of B. Then remember, what you're doing now is 10 with the straight line, 10, 20, 0, minus 8. And if you look at the solution, you will first go this way, and you will subtract this guy. Therefore, your determinant of B would equal minus 80, because the other guy is minus 0 times 20. So how do we use this in order to use this Cramer's rule that I first mentioned. I said for us to do Cramer's rule, we have to understand determinants. So now, suppose I have a linear system of two equations. And so I would write, suppose you gave me a system, so we now have an example here. This will have a linear system. And I'm going to first start with two equations. And so we have two unknowns. So let's come up with something. I'll just say 2x minus 5y equals 7. And I'll say 3x plus 10y equals 0. So just two equations, arbitrary equations, and somebody says to solve this. Remember, if I'm not using matrices, MATLAB is matrix-based. If I'm not using matrices, the old-fashioned way, I would say, for example, go here and say x is going to be minus 10y divided by 3. Then come here and substitute the minus 10y divided by 3. Solve for y, then come back in here and plug in the value and you get your x. I don't want to do that. I'm going to call this system of equations 1. What do I call that equation 1? Then I'm going to say this. I will create the matrix of the coefficients that I have here. And if you ask me to solve x, this is what I'll do. So I'll say, first of all, I'm going to be using the symbol del. So this is just, if I refer to it, if I say a term del, this implies that I'm referring to a symbol like this, as a triangle. We use that in math. So this one actually is made up of the matrix of coefficients. So it will be this: 2 minus 5, 3, 10. Just like we had when I was saying to solve a system AX equals B, I said that matrix of coefficients. So I'll have, the del will be the determinant of the matrix of this coefficient. Again, how did I create this matrix coefficient here? So if I look at this, I said let's grab 2, let's grab minus 5. Then let's take 3, and we have a plus 10. So those are the coefficients. The del is the determinant of this guy. Now, I want to solve for x. So this is using the theory first. If I want to solve for x, then I will do this. And I will say now x is equal to, and I'm going to use determinants again. Because I want x, I would look at this first column right here that has the 2 and the 3. So this side, and I'm going to replace that with the right-hand side. So I have the determinant 7, 0, and I'll repeat the next column here, minus 5, 10. And I'm going to divide this guy by the del, or by that determinant. That's how I'll find x. I'll do this again for another one. Suppose you wanted to find what, and I'll show you what the answer is. But first, let's look at what we're defining here. If you ask me to find y, remember y is that variable in the second column that I'm dealing with. I will then replace, go to your del, replace the second column by 7, 0. I will keep the very first one, so 2, 3. But now this is the guy that becomes 7, 0, and I will divide that by the del. I'm using determinants. Again, first, once you have your system of equations, you go to say the system 1. I look at the coefficient matrix. In this case, just pick up the numbers in front of your unknowns. I have two unknowns, x and y. So I have a 2, 3, minus 5, 10. I will create this guy. This guy I need to use at all times. It is going to be in the denominator. So what I have to create, the del is the determinant of this coefficient matrix. And I can solve for this in any order. So if you ask me to find x, Then I'll say x must be given as, take this right-hand side and replace this first column because I'm solving for x. X was the first variable. So replace this 2 and 3 by 7 and 0 and just repeat this. If you ask me for y, I'll say, okay, I'm not going to disturb the first column because that was the one referring to the x. Now, these guys, instead of saying minus 5 and 10, I will put these values, 7 and 0, divide by del. And so what will be a solution here? If I continue with this, then I see that my del is equal to, let me take another color here. The del is equal to, remember, 2 times 10 minus 3 times minus 5. So my del becomes, if I'm looking at this guy, so you should say 2 times 10 minus 3 times minus 5. And so we have 20 plus 15, and that is equal to 35. Do not forget that this guy has a negative sign here. So if I want to find x now, x is equal to, and I'm going to do a similar operation here, 7 times 10 minus 5 times 0 divided by 35. So here, what I'll have for x will be 7 times 10 minus 0 divided by 35. Or you can say 70 divided by 35 returns out to be 2. If you want y, y is going to be 2 times 0 minus 3 times 7. So I would write here that y is equal to 0 minus 21 all over 35. And of course, 7 into minus 21 is minus 3. 7 into 35 is 5. That's how you get the solution. So this is for a 2 by 2. You can do it for any matrix, any size of any matrix you wish. But your del, or the determinant you're working with is, for example, a 3 by 3 and so on, or 4 by 4. And those get large. This is how we solve a system of equations just using Cramer's rule. If you have MATLAB, then you can enter the equations. So let's go to MATLAB. I think I have it up. So let's go to MATLAB and just see. Maybe I made a mistake in the math or something. Let's go here and try to see what MATLAB will give us if we had this example. And I'm going to create the matrix x equals, matrix A equals 2 minus 5, 3, 10. And I'm going to solve it. Again, going back to last lecture. Now I'm about to solve this. I'll have the A matrix, and I'll have my matrix of coefficients, which of course will be x and y. Those are the unknowns. My right-hand side, if you remember the last lecture, my right-hand side vector, for example, will be 7, 0. We have the expression, if you remember the last lecture, I created, I'll just write this on the side here. The last lecture I said, suppose we have AZ equals B. I'll be able to pass in my A matrix, I'll be able to pass in my B column vector, and my result should be Z. And that Z is made up of the unknowns X and Y. So let's see how we will solve this guy in here. So that's the purpose, to solve a linear system of equations. And let's take this example that I have. Suppose I said now A equals my matrix of coefficients. So A equals, for me it's 2 minus 5. I'll separate this by commas so it stands out. Semicolon. I have a 3 and a 10. And let me just do a save as. Okay, so now if you type, remember, this is my A matrix. I'm not going to suppress anything. My B vector, remember, has to be a column vector. So the right-hand side, I had a 7 and a 0. And I'm going to put here a 7, semicolon, 0. And the solution, of course, if we call it Z, Z is equal to A slash B. Do not forget how the slash goes. But let's just see if this works, first of all. So if I run this section, okay, and let's look at this in line, and there you have it. And so you see now what I had before. So it says this is my A matrix, that's my B vector. Look at the answers. It says the very first one, your answer must be 2. The second one, the answer had to be minus 0.6. So again, I create the A matrix, B column vector. So make sure it's like this. To solve it, so this is using Gauss's method. Okay, I'll just say Gauss. So this is Gauss's method. And now let's check to see my results and compare it with what MATLAB is saying. So MATLAB says that the results you should have for X should be 2 and minus 0.6. So that's what I had by hand. So if you go and look at the MATLAB live script, it's saying that first unknown that you had is 2. So Z stores the 2 unknowns for you. Z is the very first one, what I'm calling X, should be 2, and my Y should be minus 0.6. Yes?
Is there a difference between the forward slash and the backslash?
There is a difference between the forward slash and the backslash. This guy is the Gauss's method. It's a program that has been built into the slash for you when you're working with matrices trying to solve. So Gauss's method is going that way. The way I remember it, it's not B divided by A, but I usually look at this. I don't know if I can write on the screen. No? All right. I'll come here. This result that I have here, so the question was, is there a difference between the slashes? Yes. So this result that I have, Z equals A, this slash, well, I should go that way. And then let's put in the B. Make sure that it is pointing this way. The way I remember it is it's like you're kicking B to the top. So it's like you're lying back in a chair, your feet are up, and you're kicking B to the top. But it's not, you cannot say it's B divided by, because B divided by is something else. So again, make sure that this points this way. And now, MATLAB, I just did an example, simple 2 by 2, and suppose you had a huge matrix. The beauty of MATLAB is because it's matrix based, any number elements you give it, you can give it 10,000 by 10,000, it'll give you your 10,000 unknowns. And all you have to do is to use this thing correctly. So let's just do one more. Suppose I said here that, we're just going to create any matrix now. I'm going to call this BB equals. And let's create a 4 by 4. So I'm going to say 1, 2, 3, come on, 3, 4. And the next row, I'm going to say it's 0. I'm going to try to create something that doesn't have a solution. I'm guessing here, minus 1. Let's say a 6 and a 10. I'll go to the next. Do I have 4? Oh, I'm spacing this out now. Well, so it doesn't matter. I'm going to go to the next row. Suppose I said this is 20, this is 9, this is 22, this is 3. And the last row, suppose I said this one is 5, 0, minus 1, minus 2. I'm not sure, in fact, what the solution will be. I'm just creating something. Let me run this script first to make sure that I have a 4 by 4. before we continue. Otherwise, okay. So I've created some arbitrary matrix. So suppose I had 4 equations, 4 unknowns, and suppose the right-hand side vector, I'm going to call it D. Suppose I said D equals. Remember now, I have to have a column vector. Suppose I said 10, 20, 30, and 0. I don't know, some number. It has to be a column vector. I'm going to run this guy, and it should show me that I have 4. Now, can you solve this? So this equation, you should be able to read it backwards. Suppose I said, if I have something like this, then I tell the student, what system of equations am I trying to solve? Well, suppose I said my unknowns were x, y, w, z. Then you should say it's x plus 2y plus 3w plus 4z equals 10. You should be able to read them. And I'll show you that in a minute. But let's just try to solve this. Let's assume this is correct. I mean, it's a nice system. And let's solve this. So if I want the answers, I'm just going to say solution. And solution equals, all you will do is BB slash, so kick D to the top. And let's run this guy and see what crazy answers we will get here. I'm not sure what equation I created, but there it is. So it says, basically, for your 4 unknowns, there they are. So you can make this as large as you can. I'm going to try to now create an error. Let's just go back. Suppose, and students sometimes do this. Suppose, you do this, you put a comma here. I put another comma here instead of that semicolon. So in other words, I'm creating a row vector. And let's try to see if this is my D. I run that section first. This is what D looks like now. You see what happens down here. MATLAB uses that matrix dimensions must agree. It uses that phrase so many times it's not funny. So it has to figure out, okay, what have I done wrong now? It doesn't tell you that you didn't put a column vector. A quick way to change this, if I'm lazy and I don't want to put the semicolon, just come here and put a single quote. Remember, that's how you transpose vectors or even matrices. So if I were to do this now and I run it, I should have a column vector and then MATLAB will be fine. So that inner matrix dimension must agree. I'm so sorry, but that's what MATLAB uses all the time. It's working with matrices and it talks about matrices all the time. And you have to figure out, basically in this particular case, he's telling you that the syntax is wrong. You know what you want to do, but you didn't type it in correctly. And so, as I say, you used a row vector instead of a column vector. And I mentioned that you should be able to read backwards. So what do I mean by that? Like I said, I was just reading quickly. I said, if you give me something like this, B equals 1, 2, 3, 4, something like this, I should be able to read it backwards. So if I give you a system, the coefficient matrix, and I give you the right-hand side, you should be able to tell me what the system is. So let's go here again and try to create something. And let's say you had, let's change the page. Well, actually, I should just go to a new page. I'll just go to a new page. Suppose now we had this example. I just took another one. I'm going to take a 3 by 3. Suppose I said we have this matrix, and I'm just going to write it in this form. 2, 0, 6, minus 5, 1, say 10, 3, 9, 12. I say that's my matrix of the coefficient matrix. And now I have 3 unknowns, x, y, z equals. And let's just say this one is 8, this one is 11, and let's just say this one is 16 or something. It's some crazy equation. And I say to the student, can you write the system of equations? So before I gave the system of equations and I said we should be able to generate, this is the A matrix. This is that matrix of unknowns, and this is the right-hand side vector B. So you should be able to generate them. You are now doing a matrix times a vector. So if I look at the size, so first of all, the student will say, is this possible? I look at the size of A. A is a 3 by 3. This my vector of unknown. Suppose I call it, say, V. V is what? It's a 3 by 1. Therefore, it is possible that if I multiply A times V, all you have to do is collapse this. So my result should be a 3 by 1. So this must equal a 3 by 1, which tells you that B is 3 by 1. So because we've done matrix multiplication, then I'm saying if I multiply this coefficient matrix A by this my vector of unknowns, I should get this. And so let's do that to generate the equation. So now we're just going backward. So if I want to generate the equations, I hope everybody can see it. What I'm going to be doing, because the matrices conform, the number of rows of the second one is the same as number of columns of the first one. How do I proceed? I hope you remember you do this. 2 times x. The next one will be 0 times y. And the last one will be, let me see, can I have another color? The last one will be 6 times z. That's why they have to conform. That's why the number, if I'm looking at this, is these two have to collapse. So now, if I write the equation, I should get 2x. I did not have any y. And I have plus 6z must equal 8. So when I multiply this, 2 times x, 0 times y, 6 times z, my result should be that one. The resulting matrix, the resulting vector has 3 rows, 1 column. And so I'm saying here, I take this first row times this first column. So that first row times that first column gives me my result B11. This second row times this column, only 1 column I have, should give me B21. The second row, the first, there's only 1 column because it's a vector. The last one, I would say this third row times this first column should give me this element here, 3, 1. So if I proceed, I get this. For the next one, I think you should be able to do it. See if you can do it before I do, or just try to guess something. As I write the solution for the next one, I get minus 5x plus y plus 10z. This must equal 11. So all I'm doing, minus 5x plus 1 times y plus my 10 times z. That is giving me the second value. And the last one. So the last one, I will have 3 times x plus 9 times y plus 12 times z. That should equal 16.